In this video, we're going to look at converting equations to spherical coordinates. So we're being asked to rewrite these equations that are written in rectangular coordinates into spherical coordinates. The first one is x squared minus 2x plus y squared plus z squared equals 0. And the second one is x plus 2y plus 3z equals 1. So we'll compare these equations when we're done. But let's first look at the first equation, and what we're going to do is just use our conversion formulas that we have for going from rectangular to spherical. So the first thing I'm going to do is I'm going to rewrite the equation and put the x squared plus y squared plus z squared together, and then have the minus 2x on the end equals 0, because we recognize in spherical that the x squared plus y squared plus z squared gives us rho squared. And then for the second one, we're just going to replace the x with our conversion formula. X, remember, is rho cosine theta times sine of phi. And now we can just add that 2 rho cosine theta sine phi to the right-hand side and divide both sides by rho and get our equation of rho equals 2 cosine theta sine of phi. So one thing I want to notice is that this equation, this original equation, is a sphere. So it makes sense that we might write it in spherical coordinates to make it a little bit nicer function in that case. Contrast this with part B, where we're being asked to rewrite the plane x plus 2y plus 3z equals 1. We plug in our three conversions for x, for y, and for z. And we notice we can factor out a rho out of each of those. So to solve for rho as a function of theta and phi, we can divide through and get rho is equal to 1 over cosine theta sine phi, 2 sine theta sine phi, and then plus 3 cosine phi. And this equation I don't think is nearly as nice as this one. Just looking at the equations, just comparing them, I don't think the second one's nearly as nice as the first one, which kind of makes sense because the plane equation's a nice equation to be able to explain in rectangular coordinates, but it's not a very bent object at all. So it makes a lot more sense that this is going to be better expressed in rectangular versus the sphere. Makes more sense that we're going to express it in spherical coordinates.